Welcome to the GMAT Strategy Podcast. You're here because you believe there's a better way to study for the GMAT, and so do we. We created the GMAT strategy to maximize your results and minimize your effort so you can get to the fun parts about business school and life as quickly as possible. My name is Isaac Puglia, and I've been teaching GMAT classes and tutoring privately for the GMAT for almost a decade, and I've achieved a 99th percentile score on the GMAT and helped thousands of students get into the business schools of their choice. I'm excited to be a part of your MBA journey since we all at TGS think our world can benefit from the best possible business leaders that we can find. If this show is bringing you value, please share it with your friends and family who are studying so that together we can make this process as easy and as painless as it can possibly be. Let's go.
Welcome to lesson 22 of GMAT Math Basics. Today, let's discuss absolute values. If you don't want or need help with math basics, please head back in the feed for more advanced topics. Absolute values are not nearly as common as equations and inequalities, but they show up a reasonable amount within equations and inequalities, so they are very worth understanding and discussing. Here's a quick quiz of what we'll cover today. There is a quiz at the start of every lesson in this series, and I would recommend running through all of those quizzes at least once per week until you feel rock solid with your math basics. Question 1. What is an absolute value? Question 2. How do we depict absolute values visually? Question 3. How are absolute values similar to parentheses? Question 4. How do absolute values work when they are in equations? Question 5. How do absolute values work when they are in inequalities? Let's dive in. What is an absolute value? The absolute value of a number is how far it is from zero. Many people memorize this as quote unquote distance from zero. Both are technically correct, so think about it in whatever way makes the most sense to you. What is distance from zero? Well, first of all, realize that distance is always either zero or positive. The distance from where I am to where I currently am is zero. I'm already there. The distance from where I am to the other side of the room is about 50 feet. But could there ever be a negative distance? Not on the GMAT. I imagine there are some theoretical possibilities here, but when it comes to the exam, distance is always positive. Why do we care about that? Well, if the absolute value of a number is how far it is from zero, and distance is always zero or positive, that means that absolute value is always zero or positive. That might sound very theoretical, that might sound very irrelevant, but this really matters on GMAT questions. For example, if I ask you for the absolute value of 3, how far would you say that is from zero? Hopefully you're thinking 3 units or 3 integers away. What if I asked you about the absolute value of -3? Hopefully you're thinking it's still 3. So using absolute value on the exam allows the test writers to do their job, which, as you've heard many times, if you've been following me for a while, their job is taking simple concepts like positives and negatives in this case and making them complicated and potentially confusing. That's a lot of what the exam does. The material is relatively basic, but the questions themselves can get quite complicated. If you have an operation that could start as positive or negative and then output something that's always positive, as a test writer, that's a great way to mess with people's ability to reason through complex situations. And at least in theory, this is how the test is supposed to work. It's supposed to test our ability to reason through complex problems. So that's why absolute value is important, even though the topic might seem mundane or banal or irrelevant. With that in mind, though, let's teach you how to make this easier on the test. So how do we depict absolute value visually? We use a vertical line on both sides of a number, a variable, or an expression. Okay, the way we depict absolute value visually is a vertical line on both sides of a number, a variable, or an expression. Let me give an example. If you see a vertical line from the top of a ledger line down to the bottom of a ledger line, straight up and down line, and then the number two, and then a straight up and down line right to the right of the number two, with no spaces in between the line and two, that does not mean the number two. That means the absolute value of the number two. Now, this might seem trivial because the absolute value of the number two is two, but we're just working on the basic concepts here, okay? We'll scale up to more complex situations soon enough. Let's do another quick example of how this is visualized and how it'll appear on the test. If you see a vertical line and then the number -4 right to the right of that vertical line, and then another vertical line right to the right of -4, that means the absolute value of -4. Okay, so it's those vertical lines on both sides of a number, a variable, or an expression. In the case of vertical bar, -4, vertical bar, that means replace the bars and what's inside the bars with the absolute value of -4, which is +4. So think about it this way. When you see those vertical bars, what the exam is trying to tell you is replace the bars with what's inside the bars with the absolute value of what is between the bars. Let me just repeat that because it can be a little weird and a little wordy if you're not used to it. You can hear me stumbling over it. Replace the bars and what's inside the bars with the absolute value of what's between the bars. So again, if you see vertical bar, -4, then vertical bar, the value of that whole thing is just 4. Okay, that's how you would deal with that in a mathematical situation. And it's 4 because -4 is 4 units away from 0, just in case that wasn't obvious already. So how could this play out in situations on the test? Consider putting an absolute value into an equation. How about an expression like vertical bar, -4, vertical bar again, plus 7 equals y. So I'm just taking that vertical bars surrounding -4 and putting it into an expression. The first move would be to rewrite the absolute value as 4. We'll talk about why that's the first move in a little bit, but for now, just trust that that is how we obey order of operations with absolute values. So what you do is you rewrite that absolute value expression as just +4 for the reasons I just mentioned. Then you can do the rest of the operations. In this case, you can add that 4 to 7. 4 plus 7 gets 11, which means y is equal to 11. So that's like a very basic way of how an absolute value could figure into an equation. Another example could be something like vertical bar and then the expression 10 minus 15 inside or to the right of that vertical bar, and then another vertical bar to the right of the 15. So now we've got a whole expression or a series of operations within an absolute value. 10 minus 15 yields -5, but because it has those vertical bars on either side, we replace it with the absolute value. -5 is 5 units away from 0, so we would rewrite, vertical bar 10 minus 15, another vertical bar, as just 5. That's what that becomes, because that's the absolute value of the result. If that expression showed up in an equation, hopefully now you'll know what to do with it, which is the point of this segment of the lesson. So let's build on these essentials. And if you have questions about any of this or you're not clear on what I'm discussing here, feel free to reach out to us anytime. You can find our contact information at the link below this content, or you can DM us at the GMAT strategy on current social channels. Email currently is contact@thegmatstrategy.com. contact@thegmatstrategy.com. Another important aspect of how absolute values work is their relationship to parentheses. I sort of touched on that a moment ago. This will be important for understanding how to operate on absolute values in equations, which is the most common place they show up in the GMAT. So let's answer our next question. How are absolute values similar to parentheses? The most important similarity to parentheses has to do with PEMDAS, which is otherwise known as order of operations. We must perform the calculation within the absolute value before doing other operations in an equation or in an inequality. So in this way, absolute value occupies a similar place to parentheses in PEMDAS. Let's consider a quick example. Let's say we've got 3 plus vertical bar 4 minus 6, and then another vertical bar right to the right of the 6. Okay, so you've got 4 minus 6 inside an absolute value, and then you're adding that value to the number 3. Here, we must do the computation inside the absolute value before doing the addition to 3. And in this way, absolute values obey the same order of operations as parentheses would in PEMDAS. Let me talk through this a little bit more. We cannot add 3 to 4 across the absolute value bars. That would violate PEMDAS. If you imagine a similar situation like 7 plus parentheses, 8 minus 9, close parentheses, it's really important to do what's in the parentheses first. We talked about why that is in our PEMDAS lesson, so please head back to lesson 18 of this GMAT Math Basics series if you'd like to be more clear on that. That's how absolute values are similar to parentheses. You should perform what's inside the absolute value expression before you do any other operations. Within PEMDAS, it's good to think of absolute values occupying the same place as the P for parentheses. So think about them as on the same level of importance. But if you absolutely have to deal with parentheses that are inside of absolute values or an absolute value inside of parentheses, and you're not sure which one to do first, then you always do the quote unquote innermost grouping first. For example, if I have open parentheses 3 plus vertical bar 5 minus 4, another vertical bar, and then close parentheses. So I've got basically 3 plus absolute value of 5 minus 4, all enclosed in parentheses. Then you do the absolute value calculation first because it's inside the parentheses. But if you have the opposite situation where you have vertical bar 3 plus in parentheses 4 minus 5, and then a vertical bar after that, you would do the parentheses first because the parentheses are inside the absolute value. So you work from the innermost grouping to the outermost grouping if there's like a conflict within the same step of PEMDAS. This is rare, by the way, on the exam, but if it does come up, do the innermost grouping first, whether that's absolute values or parentheses. So again, in this way, parentheses and absolute values are quite similar, particularly because they occupy the same spot in PEMDAS. Having said that, hopefully there's an obvious difference between absolute value and parentheses because with absolute value, the output is always positive, and with parentheses, it is not. Okay? Now that affects your ability to use distribution over absolute value. Again, not super common on the exam. I would actually recommend in general that you not distribute over absolute value because it creates a lot of confusion. But theoretically, just like you could distribute over parenthesis expressions, and we talked about that in the PEMDAS episode. Again, if you're not sure what I'm talking about, go back to that lesson, please, and check that out, and then circle back to this one. It's lesson 18. With absolute value, I can actually distribute a positive term across an absolute value, but I cannot distribute a negative term across an absolute value. That's going to mess up the math. And so my advice is don't distribute over absolute value. It just gets too confusing for most people under time pressure if you have to think, wait, is this positive? Is it negative? Am I distributing properly? By all means, distribute across parentheses. That's something you'll have to do quite a bit, but within absolute values, try to avoid it. That's my advice. So that brings us to the question of how to deal with absolute values in equations. Let's say you've got a variable inside the absolute value. How about vertical bar, variable x, vertical bar right to the right of x, and then that equals 3. So absolute value of x equals 3. That's our equation. This is kind of an interesting situation because there are actually two different numbers that are 3 units away from 0. We've got positive 3 and we've got negative 3. The most common way to handle this is when you've got an absolute value in an equation and that absolute value has a variable in it, you'll make 2 different versions of the equation, one positive and one negative. Doing this well comes back to understanding the basic definition of absolute value, which is simply distance from 0. Let's look at a slightly more complicated example. How about x plus 5 within the absolute value bars? So vertical bar x plus 5, another vertical bar right to the right of 5, and then that whole thing equals 3. There is debate about this, but here's what I recommend. Think about it the exact same way as the previous example. What 2 numbers are 3 units away from 0? Positive 3 and negative 3. What that means is that whatever is within the absolute value bars has to eventually equal 3 or negative 3. That's the only way we can take the absolute value of it and get 3 as the result. So that's how you can set up two equations. The first would be x plus 5 equals 3, and the second would be x plus 5 equals negative 3. Again, if x plus 5 equals 3, we take the absolute value, we'll get 3. If x plus 5 equals negative 3 and we take the absolute value, we'll get 3. So both of those would satisfy that equation. Again, some people have other approaches to this. If you have a different approach and that's working well for you, by all means, you don't need to change to this approach. If you're starting from scratch, this is the way that I recommend thinking about it, and this is what I've seen create the most success on the GMAT specifically. Those are the two situations that will result in a number that is 3 units away from 0. X plus 5 equals 3, x plus 5 equals negative 3. Once you have those two equations set up, you can solve. Let's do that. In the case of x plus 5 equals 3, we can subtract 5 from both sides, and we would get x equals negative 2. Great. That's one solution to that expression. In the case of x plus 5 equals negative 3, we can subtract 5 from both sides, and we would get x equals negative 8. That would be the other solution. So, bringing this full circle to where we began the lesson, this is why the test writers really like absolute values. You can take something simple like a simple equation, x plus 5 equals 3, and you can add a lot of layers of complexity like, wait, there's two possible solutions to this equation? Yes, two numbers would satisfy the equation, absolute value of x plus 5 equals 3. Negative 2 and negative 8. That by itself is weird enough to throw people off, and that's why we're going through this right now. So again, there are two solutions to the equation, absolute value of x plus 5 equals 3. In general, you will get two solutions when you've got a variable within an absolute value in an equation, so it's good to expect that. Let's try another quick example just to drive this point home. Consider absolute value of x minus 3 equals 11. So we've got vertical bar, x minus 3, vertical bar right to the right of 3. That whole thing equals 11. Think about this for a second on your own. Can you tell what both solutions would be? Whatever is in the absolute value has to be 11 units away from 0. There are two numbers that meet that requirement, positive 11 and negative 11. So let's set up two equations. X minus 3 equals 11 and x minus 3 equals negative 11. Let's solve x minus 3 equals 11 by adding 3 to both sides of the equation. That would yield x equals 14. That's one solution. Let's solve x minus 3 equals negative 11 by adding 3 to both sides. That would yield negative 8. That's your other solution. So x could be 14 or negative 8. Either one would satisfy the expression, absolute value of x minus 3 equals 11. That's what solving equations with absolute values looks like on a basic level. You can and likely will see situations that are more complicated, but at least you'll be able to speak the language that those more complex problems involve. And that's the focus, that's our goal with this program. Now, there's one important note to make about absolute values in equations before we move on. Sometimes you'll perform similar steps to those we just did. You'll get two solutions, but then one of those solutions will not actually work in the original equation. That can be super confusing. And I considered leaving this part out of the lesson, but it is actually really, really important for getting GMAT questions right. And so let's just quickly touch on it here. It doesn't come up much, but given that many GMAT questions are just very tricky by nature, like I've talked about already, it's worth mentioning before we jump into the final aspect of absolute values that you'll want to be familiar with. So consider the equation absolute value of x plus 3 equals 4x. On the surface, this doesn't look too bad. We can create two equations and we can solve. So let's go ahead and do that. The first equation would be x plus 3 equals 4x, and the second equation would be x plus 3 equals negative 4x, because there's two numbers that are 4x units away from 0. In the case of x plus 3 equals 4x, we can subtract x from both sides, and we would get 3 equals 3x. We can then divide both sides by 3 to get x equals 1. In the other case, the negative case, we would have x plus 3 equals negative 4x. We subtract x from both sides to get 3 equals negative 5x, and then we divide both sides by negative 5 to get negative 3 over 5 equals x. Everything seems to be going great here. If you plug the number 1, the first solution we got, back into the original expression, it works perfectly. But if you plug negative 3/5 back into the original expression, it does not work, because the left side will always be positive. It's in an absolute value, but the right side would be negative. 4 times negative 3/5 is a negative value. So you would end up getting a solution that does not actually satisfy the original expression. So what do you do about that? Just make a habit of always plugging both solutions from an absolute value expression back into the original equation after solving. Just make that habit. Most of the time, both solutions will work, but once in a while, one of those solutions won't work, and you'll save yourself a question on the exam, which is really, really valuable. Again, this is the kind of thing that can be really tricky, so it's good to expect these kinds of things on test day. The good news is that as long as you're prepared for them and you've developed good habits, you won't fall for them, and it'll be a great day. Hence our time together right now. So that's pretty much everything about the basics that I would recommend being familiar with when it comes to absolute values in equations. Everything else that you stack on top of that will really just come back to those basics. That brings us to a final important point and an important skill that you'll want to have regarding absolute values, which is how to deal with absolute values in inequalities. Like we discussed in the previous lesson, inequalities obey the same rules as equations, with one important exception. When you multiply or divide by a negative, you invert the inequality sign. If you're not sure how that works, or if you want more practice with this concept, please listen to lesson 21 of this series. All you want to remember when adding absolute values into the mix is to invert the inequality sign for the negative version of the absolute value. So recall, I just recommended that when you see an absolute value in an equation, you want to make 2 equations. One where the expression inside the absolute value yields the positive result, and another where it equals the negative result. When you've got an absolute value in an inequality, invert the inequality sign for the negative version of the expression. Okay, that might be worth a flashcard or just a little bit of repetition here. When you've got an absolute value in an inequality, invert the inequality sign for the negative version of the expression. So absolute value in an equation or inequality, typically we'll want to make 2 versions of the expression, one positive, one negative. We just talked through a couple examples of that. When you're dealing with an inequality expression and you're creating the negative version, you want to invert the inequality sign. So if it was a greater than sign, flip it to a less than sign. If it was a less than or equal to sign, flip it to a greater than or equal to sign. And again, if you need more help with inequalities, that's the previous lesson, lesson 21. Let's demonstrate this. Consider the expression absolute value of x plus 5 is less than 3. So I've got a vertical bar, then I've got x plus 5, then I've got another vertical bar right to the right of 5. To the right of that, I've got a triangle with no base, rotated 90 degrees to the left. So the less than sign is what that's called. And it's opening up toward the number 3. That means absolute value of x plus 5 is less than 3. Let's make 2 versions of the inequality, one positive and one negative. But for the negative version, let's invert the sign. Our positive version would be x plus 5 is less than 3. And our negative version would be x plus 5 is greater than negative 3. That's it. Then you can just simplify those 2 expressions. For x plus 5 is less than 3, subtract 5 from both sides of the inequality. That yields x is less than negative 2. For x plus 5 is greater than negative 3, subtract 5 from both sides, and that yields x is greater than negative 8. That's it. That's everything that you should know about the basics of inequalities. There are, again, plenty of other advanced moves to make, but you should be well set up to learn and understand those advanced approaches now that you've got the basics down. We'll have some high-quality practice material ready soon if you want to drill these concepts. For now, using a popular generative AI chatbot should suffice. I recommend a prompt like, please generate 10 inequality questions that involve absolute values that will help me improve my basic GMAT math skills, or something like that. Tell the AI you're studying for the GMAT, tell it you want 10 inequality questions that involve absolute values, and tell it that you want to focus on basics. I found most AIs can handle this without error, but as with all current Gen AI, please double check the answers it gives you just to be 100% sure that they're accurate. Like I said, if you have questions on any of this material, just reach out to us. We're at the GMAT Strategy on current social channels. Most popular channels that we receive messages on are Instagram, Facebook, and Reddit, but you can comment on YouTube. Totally up to you, whatever platform you like best. As always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the GMAT, please head to our website, thegmatstrategy.com, which is linked in the description of this content. And check out our free video on how to reach your dream GMAT score in half the normal time. In the meantime, this is a weekly show, so please subscribe and please stay positive and stay consistent with your studies. Talk to you all soon.